Colleagues, here are some additional comments about balancing with the DC23 data collector, because there are usually some questions. The first question is, where is the 0 degrees, and from where we have to calculate the angles on the rotor. You fix the 0 degrees when you first install the trial weight. So here we have installed the trial weight, and when we enter in the data collector the position of this trial weight, we fix the angle. Before this, the angle is not fixed at all. You may count the angle from anywhere. It can be from the mark, as usually people do. It can be from the for example, this hole in the shaft, from the shaft position. It can be from the trial weight. So usually when I do the balancing, first thing that I do is I point on the shaft somewhere and say that this is 0 angle. For example, it can be here and write here that this is a 0 angle. It can be here. In this case, I will remove this mark and will say that this is a 0 angle. Or I can write down anywhere the 0 angle. For example, here I can say that this is 0 angle. So this is important. The 0 angle you fix the first time you enter any angle to the data collector balancing program. So here I entered, for example, the trial, this is trial weight, the first trial weight, 11 grams on 100 degrees. So this is 100 degrees from my mark, from this position. So this is very important, that you can calculate angles from any point, but this point should be fixed as soon as you enter it to the data collector for the first time. This is important. The second issue is in what units you measure the amount of weights, the balancing weights or trial weights. It can be any measure. I have the scales and I calculate it in grams, so I enter it in grams. But for example, if you do not have scales, you can enter it in the number of washers or trial weight or weights you put here. So for example, I can say that this is 5 washers and the amount of weight is 5 washers. In this case, it will calculate you. Please add 3.6 washers to some degrees, and this will be, and you have to cut 3.5 washers. The third probably measure or magnitude can be centimeters. If you have to weld some mass here, you can weld here 5 centimeters of welding rod. So in this case, for your welding apparatus, you measure 5 centimeters of the welding rod and you put it here like this. And enter that you have 5 centimeters or 5 weight equals to 5. Then it will calculate you and say, next put 6.7 centimeters of welding rod. On the same rod you measure 6.5 centimeters and you put it somewhere on the shaft where it tells you. So this is also important. Also we have discussed in the previous video that to calculate the amount of trial weight you have to look at the rotor and find here some weights that are already installed and take the maximum of what is here on the rotor, and this will be a good amount for your balancing. If nothing is installed here or you don't see it, we have a tool for the calculation of the mass, so something like this. 7 calculate mass 7. We can go here and see and enter the parameters like rotor weight. So what is the weight of this rotor? Probably it will be 20 kilograms. Then the installation radius in millimeters. So installation radius is from the center of the rotor till the places where you install it. So this is installation radius. Then maximum vibration amplitude that you have on the rotor. This is what we have measured. Then the rotation speed, we have also measured it. So for example, here I enter in kilograms, something like 20 kilograms for this rotor. The installation radius here is approximately, I think that something like 12 centimeters. So enter 12 centimeters, something like this. And now we can calculate 5 button. It will be 87 grams. So for the rotor with this specification, it is 87 grams. That is the calculated recommended trial weight. Maybe I missed the mass of this rotor. If it will be something like 10, maybe here it is 10, I don't know the mass of this rotor, it will be more correct. But what I am saying is it's very important that the best way is practice. Practice is what weights we have installed on this rotor already till before our balancing. Also, one more issue is that after you have done the measurements, for example, we install this trial weight, we have done measurements, we have a few tools here. The first is skim. You can also use it once we set up. So it's something like this. It shows you this is the vibration that we have measured. So we have measured 232 phase, and the vibration level that we have seen here back. This is what we have measured on the second bearing of our machine. Each time you measure something, it will show you on the graph what you have measured in what place. One is horizontal direction, one is radial direction. So we can go back. One more thing is the graph. This is the graph for the balancing. So if we say 4, you see that initial vibration like this, trial vibration is like this, trial weight was installed here, and you have to move the trial weight to here so that the vibration will be like the final vibration what is present here. So this is a vector calculator that you can use for your understanding or for your practice. One more comment that we have here, I can just leave here. We have a vector calculator in the balancing software and in the vibration analyzer as well. So the vector calculator will allow you to sum weights and to subtract weights. So we can decompose weight by regular structure. For example, here we have a regular structure, and it has 20 degrees in between the angle, in between the installation places. So it has 18 threaded holes here where you can install the weights. So in this way, for example, if we select this, it says that we need to install something like 11. We need to install 11 grams to angle like 34. Enter 34 degrees like this. Number of installation places here on my rotor I have 18, and I don't have limit on the maximum weight, and I can calculate the decomposition result. So it says that I have to install this amount on position number 2. Position number 2 is 20 degrees, and 7.78 on position number 3. It is something like 40 degrees. So on these two angles, I have to install these two weights. So this is decomposition on a regular structure than I have here. For example, if I have a maximum, if I have a fan or turbine where I cannot install more than 2 grams, for example here, the maximum amount that I can install is 2 grams. And in this case, the calculation result will be like this. I have to install 2 grams on very many locations. On locations like that, and some additional on locations like this, and it will bring me my weight that is intended to be installed. So this is quite a wise calculation. So I say cancel. That is 6. I can also decompose it by 2 angles. For example, you see that in the previous video it asked to install 1 gram, and they don't have 1 gram weight. So let's see that I need to install 1 gram at 2, and I can split them among two angles. I need to put them onto 0, for example, and I can split it into two positions. One position is 10 degrees, like I have to enter 10 degrees, and another is 27, is 970, something like this, between these 2 degrees, for example, and I can calculate it like this. So this is the decomposition of my weight among any of the two locations. So this is also clear. Cancel. And also I can sum weights. For example, on my rotor here I have 2 weights installed. One is installed in 20, 40 and 60, and another installed on 100. So I can sum them like this. So I select sum weights, and the first weight that I have here is something like 6 grams at 60 degrees, and another is 11 at 100 degrees, and 11 grams, like this. And I can calculate the sum of it. So instead of these two, I have to install 16 grams on 86 degrees. So this is also a vector calculator that is included with the data collector, and you can use it in your practice. So thank you very much for your attention. Stay tuned.